All right, thank you everybody for joining us for the 2016 Luther Brady Lecture. It is a great honor for me, and it is with great pleasure that I have this privilege to introduce Dr. Bahman Emami as our 2016 Luther Brady Lecturer. Bahman has been a real luminary in the field of radiation oncology. He got his medical degree at the University of Tehran, did a pathology residency before switching gears and doing a residency and fellowship at the New England Medical Center. He's been a real force in the field of radiation oncology ever since. Many of us know him either through his time at WashU Mallinckrodt in St. Louis or through his decades of service as chair and leader at the Hines VA Loyola Medical Center, where I have the privilege of working with Bahman on a daily basis, and Bill Small has the pleasure of inheriting the role as chairman of the department at Loyola. Through his many years of service in the field of radiation oncology, Bahman has written hundreds of papers in many of the standard venues, the Red Journal, JCO, Cancer, American Journal of Clinical Oncology, Technology, Cancer Research and Treatment, et cetera, along with some very high-profile, high-impact journals, New England Journal of Medicine, Journal of National Cancer Institute, et cetera. But there's one paper that truly stands out. In 1991, Dr. Emami was selected by the NCI to chair a task force that was charged with analyzing the tolerance of normal tissue to therapeutic radiation. The final product of Dr. Emami's task force was a paper published in the International Journal of Radiation Oncology, Biology and Physics, Normal Tissue Tolerances to Therapeutic Irradiation. That was in 1991, 25 years ago. When you think about it, what we do today when we're analyzing our DVHs and when we're talking to our dosimetrists about dose volume constraints, what we're doing is applying the principles that were outlined initially by Dr. Emami in his seminal paper. So now, 25 years later, Dr. Emami is here to give the Luther Brady Lecture, the Emami paper, a quarter century later. So, Dr. Emami, could you please come up? Before we get the lecture, we have to give out the award. Here you go, Dr. Emami.
Thank you.
Thank you.
Thank you.
Congratulations.
Thank you very much, Jim, for great introduction. I'm honored to be here to give Dr. Brady lecture. It's a great privilege. Truly, I'm happy as much as I can be. A little story. About some 15, 16 years ago, when I was on the faculty of RSNA, I was walking in the hallways, and this is a true story. I saw Dr. Brady is walking in the hallway. Dr. Brady is always kind to me. He's always a serious person, but he's always kind. So I saw him walking, and I greeted him. He graciously acknowledged my presence. And I saw him is down. I said, Dr. Brady, what's going on? Why you're not yourself? And the answer, Dr. Brady, I don't know, remember or not, but this was exact word. And he told me, Bahman, this generation will come and go and will forget and will not know who was Brady, who was Fletcher, who was Delgado. I cheered them up. I said, Dr. Brady, not only this generation, but generations to come will remember who was Dr. Brady, who was Fletcher. And I'm not sure, actually, we went after for lunch or not, or if it was, he paid for it. He was always different from Phil Rubin. Dr. Brady, now that 16 years later, I have the honor giving your lecture is testimony what I told you that day. Generations to come will remember who was Brady, who was Fletcher, and etc. Now, but let's find out why some of these. One, number one, who's Dr. Brady? By everybody's account, he is a true gentleman in true word. Other piece, all the accolades and the medals and honors that we all, every one of us, we wish to have one in a lifetime. He has a collection of those. A university professor, 24 gold medals, 5 honorary degrees, and the other one, another part of it was his academic activities, or I call it his civil service to radiation oncology. Chairman of RTOG for many years, editor-in-chief of his own journal. He was the honorary director of NIH Foundation, and you name it more. Now, then the other part of his, what I call work. ACRO, founding president, ASTRO, chair, president, American Radium Society, chair, Inter-Society of Council of Radiation Oncology, chair, RSNA, chair, and so on and so forth. In addition to all of these works in the profession of radiation oncology, Dr. Brady is very heavily involved in the issues of art and music, as you see some of them. He is in the board of directors of many art institutes, Metropolitan Opera, Opera Company of New Mexico, one of the famous ones, and again, so on and so forth. And also, on top of it, he has been very prolific. Over 700, although this slide is a little old, over 700 publications. Most of them are seminal, most of them are classic. So these are part of the reason, Dr. Brady, that generations to come will benefit from these and will remember who was Brady. My talk today is the paper we wrote together with a group of my colleagues at the time of 1991. And it's fitted that the history of this paper, how it was created, is also part of the revolution we have had in radiation oncology in the last 25, 30 years. It cannot be separated. So reviewing of the history of this paper also tells us something about what revolution has been, where we were, and how we are here today. And that in turn shows what was the contribution of greats like Dr. Brady and Fletcher and others. I will not talk about these: radioactive water, radioactive cream, radioactive lotion, radioactive bath. So these are kind of predates what I'm talking about. I will start from somewhere from teletherapy era. However, if any of you are interested, products are still available. This is radiation water. And in order just to make sure that no harm can be done to you, it's very important to notice that is in triple distilled water, just to make sure that everything is in perfect shape. Now, this is the time I'm going to start talking about this is probably first patient treated with megavoltage. It was a book, Morpheus book. Some of the old timers will remember. I have one copy. Thick book. This taken from that book. This patient does have a lung cancer, and I can assure you is not in that right lower lobe, as you see. But has patient had lung cancer? Probably you can notice there's a little fullness on the right mediastinum. There. This is how it was treated for our young colleagues, and not so young colleagues. 6 beams. All that's a contour or a presumed contour of the chest. It doesn't matter where it was lung, where is spinal cord, where is the bone, where is the air. We didn't know. We didn't want to know. We did want to know, but didn't know how to do it. And this is the quote-unquote isodose of that treatment of that patient. And the only thing you have to remember that the calculation was done at one point. Entire chest represented by a single point at the cross-section of central axes of those 6 beams. 1 point representing the entire volume. No IGRT, no anybody else. This is a patient after treatment. Back of the patient after treatment. This is 2 years later. We did a little better with head and neck. This is from actually patient when I was resident. We used to go examine a patient in the examining room and take a laundry mark and draw things on the patient's face, and then calculate him central midline and calculate. Did know, but didn't know what to do with where was the parotid, where was the other glands, where was the tumor, where is the bone, mandible. They are not included in this kind of calculation. We did a little different in the belly. We measured AP diameter, and then this is a very peculiar. That wire is a very flexible, mobile wire. However, we imagine that's a kind of, it's going to stay the same shape. And then we take him to the paper and try to put some doses to it. And this is a paper, just a short paper came out last week in Red Journal, one of my colleagues, one of my friends. And it shows how we used to treat breast. And if any of you want to know that I cannot point that out, the one in the lower, in the midline is the chest wall, and then you see next to it is axilla, and the other one is the supraclav. So in case you want to know how post-op chest wall was treated. And then we had a research tool, tomograms, and the artist would imagine where the tumor, and if you think that white stuff there is tumor, thinking, the artist thinking was that tumor was this one. So, and the important part was the physics. Calculation was done a single point, central axis, cross-section of central axis of all the beams. Content of the body was water, so we didn't care. We did care, but we didn't. The only thing, heterogeneity was no issue for us, or different tissues had no problem. But we used to give something to our lung, about 20% some patients. So human body was a bunch of barrels, top of each other, various dimensions, and filled with water. And it was in this era, by the way, we had the tools. We had the blocking tools. And if you look at the middle one is I cannot show it with this. The middle one is the spinal cord block, the one in the corner block, kidney block, lung block. So if we wanted, we could block some of them with external topography of the chest or a belly somewhere. Guessing that where internal organ is and how correspond to any of these blocks. It was in this era that the book came out, Phil Rubin and George Casseret. This book governed our practice for a decade or more. This is the book. I still have a copy of it. Clinical Radiation Pathology was the anecdote of a collection of anecdotes people thought they know about normal tissue complications. And this is the time the concept of TD55 and TD555, which still we use it in a sense, but doesn't mean much anymore anyway. We don't have a 5% complication as a standard of doing business. That probably lawyers wouldn't like it. But anyway, that was a concept, came out from Phil Rubin, and we continued to do it. Then came an era of CAT scan. Diagnostic radiology started to use CAT scan. So if they're using it, why not we use it? We started to use CAT scan, and but it was only one slice. Normally it was central axis. And then we got a little bit more smart, and I remember at Malincrot, I had a deal with the diagnostic guys, Harvey Glazer, that I had one CT central axis, 2 cm above, 4 cm above, 2 cm below, 5 cm, 4 cm below. So we got about 5 slides, it's cheaper, $150, as opposed to complete CT of $450. For doing 5 slides, we had a better version, better view, better understanding of how we were treating, let's say, chest. That's what I did. So I started to see using CT scan treatment era. And this is the time the information came out that started publishing on using CAT scan on treatment planning. And the first 4 are basically on planning. I was involved in the second one. And the last one is actually, number 5, is actually on the treating of actual patients. About 32 patients we treated that way. So finally, gradually we are getting to use from 1D to 2D and beginning of to seeing something about issue of 3D. So this is the time we started to see something about 3D CRT. And this coincided with the significant progress in computers and graphic software, which was good luck. And then now we are starting to have tools for Takahashi's idea of 3D CRT, which he had some 15 years ago idea, but he didn't have tools. Now we are starting to have some tools. And at that time, NIH, NCI did probably one of the most wise decisions, set up a bunch of contracts. And to my opinion and many, these are probably the most valued work of NIH. They got more information, more work for the buck they paid us, which they didn't. So this is the first one was the heavy particle for protons and neutrons, dominated by the MGH. At the time, they had a lot of experience for it. Then it was the photon contract that WashU, I was involved in it with Jim Purdy. Jim Purdy was PI, and I was his quasi-co-PI. We got heavily involved in this photon contract. And then was electron contract, again from WashU, I was involved in it. Then it got tools contract. So the last contract, there was another one after this for brachytherapy, but I'm not showing that. So this contract was told us how to come up with tools that those stuff that we prepared part of the previous contracts, how could be used by community in the field of radiation oncology. So here is the one that at that time industry became interested. They have genius engineers. They got the ideas from those contracts and they got to work. That's where you start to see 3D tools becoming widely available. And then while we were doing 3D planning, part of that tools contract and photon contract, we found out there is a clinical need for partial volume tolerance of radiation, because that was what we were dealing with it, and we needed something. And that's where this paper was created out of needs of those contracts. Although, as the first one tell you that although my name stuck to it, but credit goes to all those people, 8 clinicians and physicists, they actually worked on it. So we all share the credit together. This is a paper, total citation as of December of this year, 3,100. And it's coded, given to me by one of my physics colleagues. These two information, I even didn't know about it, that ranked number 1 in terms of citations in all Red Journal publications in history of Red Journal. Again, I didn't notice. My physicist, my friend, gave the information. This is the citation. Thing that you remember that this is 1991. It started to really pick up when myself and Dr. Purdy, we initiated the history, the ACRO school to teach communities around the country how to use 3D, and then about almost 2000. And then from there, picked it up. So from research arena, this is heavily used up to the date. It still continues after 25 years. It's still getting about over 200 citations per year. This is the base of it. We started to work, but geez, we didn't have nothing to start with. So I put some arbitrary criteria. We put on limited number of organs, because that's all it was in contracts. Only conventional fractionation, only adult, no pediatrics. Only most clinically important, usually severe endpoint. And the only thing we did was kind of new at the time, was divided these organs to 1/3, 2/3, 3/3. That was the one that made it different from past. Even with those limitations, we did have very little information, and even with those, we had very little information. Dr. Gladstein at one time mentioned that there is no data. He's right, Eli. Eli was right. Information was even more scanty if you look at the partial volume. It was just nothing there, nothing. Now, we got some of those information from some of the extrapolation from data. However, what I did at the time, I was chairing the committee, as Jim mentioned, I chose these 2 physicians from each contract and gave them the areas for investigation, the areas they had personally more experience of treating those patients. So the data you see on those tables are the heavily experienced expertise of those clinicians worked in that area. For example, those days I used to do lung, thorax, so I took over to write the lungs. Or I believe Larry Koya was doing GI, so he got that one, or so on and so forth. So with all those limitations, we had no information to start with. As has been said by the famous lawyer, we did what we could with what we had. We hoped at that time that this paper would serve as an initiation point for systematic research on the volumetric, dosimetric information, measurements, and the correlation of those with clinical complications. And now we hope that this information, would make significant contributions to the understanding of those volume relationships or normal tissue tolerance. The ultimate goal, obviously, would be the significant reduction of radiation complications and improved therapeutic values, ratios, and finally, quality of life of our patients. So 25 years later, let's see what we have done and where we are and what has been impact. Now, one, there has been, as we hoped, there has been extensive research, because in that paper, in 4 places, we wrote down, guys, ladies, we need research in this area. We know nothing about it. Please do research. We need research. And that goal has accomplished. Extensive research has been done in the last 2.5 decades on normal tissue complication. And we hope will continue next 25 years. And the culmination of that was the work, where is Larry? He put together the Quantec, which was the culmination of coming down, looking into, am I right? Looking into what was research done since the paper, initiation of that paper. And I really hope that we will have more Quantecs years to come, because research hopefully will continue. These 3 papers came, 2 of them came the same time, and the next one was done by Mary Lee, was my kind of protege and my fellow, my younger staff. And these 3 has, to my opinion, has made significant contribution to the practice of radiation therapy, technically and medically, which I think something has to be considered. As I mentioned, we started about some years after that, we saw a lot of people buying these machines, 3D machines, and they are producing by, the manufacturers are giving them and selling them, but they just didn't know what to do with it. So I initiated and kind of founded, and Jim Purdy helped me out. And we started ACRO 3D school. And some of people may remember that the Arnie was, right? He's one of the faculties, and few of people, they were faculties, remember those days. We were running around the country and teaching people how to do 3D CRD. And that was useful. It was our goals that then it came the true impact of that paper, again, was the use of informational tables by physicians, treating thousands of their patients. And I hope that was the reduction in the complications to improve therapeutic ratio. So our main goal was accomplished. That was very important for us, that goal. Now, other impacts. These are from here on, it may or may not be directly evolved of that paper, but there has been, one cannot deny that it was kind of impetus of that paper to see some of this stuff. 1, awareness of existence of other organs other than just spinal cord and brain and lung, which was at the time. And knowing that the injury of those other organs can also impact the injury of radiation injury of those organs can impact quality of life. For example, this is one of the papers of that era, and you see there are only about few organs, and they are whole lung, and the doses was central axis doses, right in the middle of nowhere land. Keep in mind, this is the RTOG 9003 head and neck protocol, forearms, Karen Food protocol. There was only one organ, OAR, was listed, only spinal cord. And we had a dose tolerance on it, dose constraints on it, nothing else. Protocol, these tables, we put together 26. And current RTOG head and neck protocol has 10 of them. And more important, in our department at Loyola, we have tables like this, and many of you have it. We have a list of these tables. This is for head and neck. We have it for GYN. We have it for lung, and etc. And you see in the table, in the endpoint, the parameters, you see, organ, you see, and the doses either taken from Quantic or taken from those tables, put together, and then the goal that treatment planner should do it and write on the one column before last. And then at the end, if they didn't achieve, well, tell us why. So this kind of assures this, and this is a continuation of that table, assures good quality of patient care and hopefully reduction of controlling the normal tissue side effects and complications. Changes of focus of endpoints. We don't have to look at these complications. Some of you have never seen this. But this was the complication of the bygone era. Now we are talking about, for example, we used to have a necrosis of the rectum. Now we are talking about maybe a couple times diarrhea every 3 days. So we used to look at the necrosis, my grade 2 erythema. So these are changes of the organs as a result of, again, progress that paper was, I hope, was part of it. Initiation of grading. Now we started to see grading of these. There was no grading before that. And 4 years later, a paper by Jim Cox came out talking about toxicity criteria based on those, looking at those tables and kind of looking at how severe was, so that we start grading. Although after some years after, as we always know, Dr. Rubin wanted to have something of his own. He put together this SOMA length, extensive 43 pages, to be used every day by dosimetrists, but it was so complicated nobody uses it anymore. At least I don't know anybody using it. And the reason is this is one of them. For brain example, you have to have your dosimetrists read all of these, and that's why it didn't work. Initiation of clinical implementation of dosimetric complications, more detailed partial volume. So that's the era, as I showed you from Mary Lee's paper, we started to see V's. V5, V10, V20, V30 now. Every organ has different V's and different P's, and kind of we use them in our dosimetries and kind of constraints of our planning systems. There are complications and side effects that at that time we thought they were unavoidable, but now actually preventable. For example, we used to tell patients that unavoidable complication is xerostomia when you treat head and neck patients. Now we are saying that even the RTOG is a very conservative way of looking at things. They are saying less common or more common or less common. Actually, I don't tell my patients, most of patients, they will have xerostomia because they won't have it. And all of them, finally, is a significant reduction in severe side effects and complication. That was the ultimate goal of that paper, of that work. And as I said, credit goes to all those individuals, 8 clinicians, Mike Goetin and John Lyman, that they were co-authors, improve quality of life of our patients. Now, where will we go from here? Number one, I wish and I hope we do more research, and it's going on, as I hear that a lot of research is ongoing, and I hope we will have more Quantics or things like Quantics in the future. That's important. I hope it doesn't take 20 years to get one of those. Hopefully every few years to see some of those. We need predictive models, more realistic ones. Although some my younger colleagues, they think that we have a model to put everything. Quantic did some of these, but it's still a long way to go to have models that we can actually day-to-day use in clinics. Some models have been promoted. I used Lyman model, that's about 40 years ago. But we need more better models. Models that there are some issues that we should be incorporated in models that we don't have them there yet. Some of them being done, but not yet. Just look at the whole thing here. For example, host response to radiation. Smoking, when I talk about V20 of lung, V20 of lung is different from a 28 years old person as opposed to VA patient I see that has been smoking for 45 years. Those V's are different V's, but we're not there yet. Now, again, the same thing. For example, when we are talking about xerostomia, which parotid? Parotid is easy because all the research is done on parotid. It's easy to contour, easy to measure. But how about the others? Minor salivary glands, they contribute to that. Submandibular gland, 20%. And the endpoints, whether salivary flow or the clinical xerostomia. And then treatment. This is an issue can be done and is being done. This area probably is getting more attention nowadays. The dose fractionation, high dose fractionation, now SBRT is being very popular. Dose rate, overall treatment time, energies. Now we have low energy on the IORT. X-ray, though, is different radiation and is a different ball game. So those tables doesn't hold anymore. And then other things. Now we have chemotherapy added. Now we are immunotherapy. We got to think about some of those in the models because they make a difference. Objectives, as I said, whether it's for example, here is a saliva flow or it's clinical xerostomia and which grade, how we put them in models. And then another variable, endpoint, is it late or early? Is it radiology? Is it clinic? Is it how the duration? We usually forget about that one. And so far, so on and so forth. These are all issues that has to be addressed in the models, but we are not there and we need a lot of research in that area. So, in conclusion, in the tradition of the effort to improve the quality of practice of radiation oncology, as has been done by greats like Brady and Fletcher and others, with the ultimate goal of better serving our patients, it is incumbent to our profession to generate meaningful models that reflects the true underlying mechanism governing the tumor control and normal tissue complications, and to teach the next generation how to use and exploit these models to better improve the practice of radiation oncology. Thank you very much. Thank you very much.
Well, again, I want to thank Bahman for a wonderful lecture. And I'd also like to make an announcement. We have something quite exciting connected with this lecture. I'm announcing the establishment of the Dr. Luther Brady Foundation of ACRO. And this is very, very important. And we're going to have brochures in the back of the room, but you're going to hear about this many times in the coming months. The reason for this foundation, of course, is to honor and perpetuate the great achievements and contributions of Dr. Brady. I'm very honored to be the president of this foundation. And so I wanted to say a little bit about why are we doing this beyond honoring this luminary in our field.
First of all, we want to support this lecture series. And so this is going to be a way to support that and bring in wonderful speakers who I'm making stand up here. I feel bad. Well, with the support these wonderful lectures in the future in perpetuity. Also, in the tradition of Dr. Brady, this is to bring support to young people, trainees, and others for research and educational ventures such as the scholarships, the GROW scholarships that ACRO is so wonderfully involved with. And also we're leaving open other potential educational activities as they come forward. So please consider becoming a member and donating to this foundation. And as of course, Dr. Brady leads the way on so many things in our field. He also, with a generous donation, became the inaugural donor to this foundation and has agreed, unbelievably, to match donations dollar for dollar. I mean, this is an incredible gift on his part. So I think that says it all. I think it's just going to be a wonderful thing, and I hope the rest of the meeting goes as well as it has gone so far. I think it's been terrific. Thank you very much.